supposed to do this? I don't know anything about the history of atoms.
I'm here to help you with your chemistry homework.
I can't learn this. I might as well just get an F.
Never say never. So if you're watching this video, you're probably having trouble with your chemistry homework. So today I'm going to talk about some of history's most famous chemists, starting with Democritus. Oh, hello there. I'm pre-Socratic philosopher Democritus, born in 460 BC in Abdera, Thrace, a small Greek village. While studying the atom, I first hypothesized that the universe is made up of atoms and void being empty space, and that atoms are the fundamental building blocks of everything in the universe, being indivisible, solid, and indestructible. With this, I came to conclude that all things in this world are made up when atoms collide and become entangled with one another. I also believe that all atoms are devoid of any qualities and can be defined by 3 quantitative measures: shape, arrangement, and position. Another belief I'm known for is that all the qualities that we see in objects, as in touch, taste, sound, comes from apparent knowledge, and the real truth is found in the depths of the universe. Unfortunately, I have made no experiments to prove my theory is true, although my theories have been passed on through history and elaborated on by chemists around the world. So, next up, scientist John Dalton will talk about his atomic theory. Take it away, John.
I have 5 main points to my atomic theory. First, that elements are made up of extremely small particles called atoms. Next, atoms of a given element are identical in size, mass, and other properties. Atoms of different elements combine in simple, whole number ratios to form chemical compounds. And lastly, in chemical reactions, atoms are combined, separated, or rearranged. To conclude, atoms are tiny, indivisible, indestructible particles, and that each one has a certain mass, size, and chemical behavior that was determined by what kind of element they were. Okay, bye-bye, children.
Bye now, bye-bye. Yeah, bye.
Now that you guys know about Democritus and Dalton, we'll move on to J.J. Thomson.
Oi! Oh wow, J.J. Thomson!
Thompson! Are you J.J. Thomson?
Hello, I'm J.J. Thomson.
So good to meet you. I gotta record this. So tell me about yourself.
I was born in 1856 in Manchester, but then I started studying cathodes. After studying cathodes, I learned that there were even smaller particles than atoms called electrons.
Wow, and what do you think the atom looks like?
I think it looks like plum pudding.
Now we're going to talk about Ernest Rutherford.
Mr. Rutherford, can I have a word with you? It's Jimmy Gilpin from the news. Mr. Rutherford?
Hello, Fraulein.
I'd like to ask you a few questions.
Why, of course, follow me.
So Ernest, tell me a little bit about yourself.
Well, I was born in 1871 in New Zealand. As a child, I was always fascinated by chemistry and physics, which helped lead to my scientific career. It all started with a gold foil experiment.
I launched alpha particles at a thin sheet of gold foil surrounded by photo paper. Most alpha particles went through the gold foil while some bounced off, approximately 1 in 8,000. It can be concluded that an atom contains a positively charged and dense nucleus, though the rest of it is mostly composed of empty space.
Up next we're going to talk about Niels Bohr, and he's going to talk about his Bohr's model.
Oh, hi there. I'm Niels Bohr. I'm just simulating my planetary model right now. It's how I view the atom. I was born in 1885 in Copenhagen, Denmark. I stayed at the University of Copenhagen, and where I got my master's degree in 1911. I then theorized, with the help of J.J. Thomson and criticism from Albert Einstein, that electrons have set paths, but when they switch in orbits, but when they switch paths, they emit radiation.
So we've come down to our last scientist, Erwin Schrödinger. Erwin Schrödinger.
Oh hey, I'm Erwin Schrödinger. I was born in 1887 in Austria. My most famous theory is called Schrödinger's cat. Basically what it means is that it's a hypothetical situation in which if you put a cat into a box with poison, it would eventually die. Meaning that at the same time, the cat could both be alive and dead simultaneously.
What the hell does that mean? And what does that have to do with chemistry?
Well, not a lot. It's more physics. But it really has to do with my quantum theory, which pertains to atoms. See, the quantum model is very similar to the Bohr model, in that in the Bohr model, electrons revolve around the nucleus. However, in the Bohr model, they're on set paths called orbitals. This is the difference between the Bohr model and the quantum model, because the quantum model features clouds of probability, which are zones that anywhere in that zone, the electron could be at any given moment.
Oh well, that's all the time we have for today. Make sure you tune in next week for the next episode of Breaking Chemistry.
Oh, I get it now.
There's a back.